Hi there, welcome back to MA211. Let's continue talking about undetermined coefficients. We're just going to talk about a little nuance that can happen when you're trying undetermined coefficients. So let's suppose that we wanted to solve the ODE y double prime plus y equals sine t. So this ODE. Now the natural guess, you'd say, okay, well, probably a particular solution is a sine t plus b cosine t. And that is indeed, that's the perfect first guess. So, okay, you go along, take some derivatives, take a second derivative, plug everything in. Remember, you're in the business of finding coefficients a and b so that this part is y double prime plus y you want to be sine t. But if you look, this left-hand side entirely cancels each other. So you want to find a and b so that 0 equals sine t. Well, that is clearly not going to work. And so what this means is that your initial guess was wrong. And so you should be saying, well, that seems weird. I thought I followed all the rules you've told us so far, and you did. Your initial guess was fine, except for one little thing. So if we look carefully at the original ODE, remember it was y double prime plus y equals sine t. Let's just solve the associated homogeneous equation first. Now you're going to need the general solution to the associated homogeneous equation anyway, if you want to write the general solution to the inhomogeneous equation. So let's just go ahead and solve it first. So yh double prime plus yh equals 0. So the characteristic equation is r squared plus 1 equals 0. That has roots plus or minus I. And so the general solution is yh equals c1 cosine t plus c2 sine t. Okay. So what's that mean? It means anything in the form a constant times cosine t plus a constant times sine t is going to solve this associated homogeneous equation. Okay, what did we do? When we started the method of undetermined coefficients, we were guessing that this thing, a sine t plus b sine t, solved the inhomogeneous equation. Well, that can't be. We just saw that anything in this form, this thing right here, solves the homogeneous equation. And look, this thing is in that form. So the long and the short of it is, our guess was accidentally a solution to the homogeneous equation, not the inhomogeneous equation. And you can see that by first solving the associated homogeneous equation, getting its form, and then saying, hey, am I about to guess a solution to the homogeneous equation instead of the inhomogeneous equation? And in this case, yeah, look, we were guessing a solution to the homogeneous equation, not the inhomogeneous equation. So what should we do? I'm just going to tell you that if that's the case, if your guess accidentally solves the homogeneous problem, you just go ahead and multiply your guess by t. So what we're going to do is say, well, I originally thought that it was a times sine t plus b cosine t. Instead, I'm going to multiply that thing by t and get my new guess. I'll go ahead and plug that guess into the ODE, and lo and behold, everything works out beautifully. You get a coefficient of b being negative 1/2, and here you get one particular solution to the ODE. You should go back and read through this carefully and do all of that work by hand yourself to make sure that it makes sense to you. So let's try this. Okay, so here's the general solution. Here's the homogeneous solution that we found. Here's the particular solution that we found. Here's the general rule when you're doing undetermined coefficients. There should be no terms in your initial guess, yp, so your initial guess at a particular solution, that solve the homogeneous problem. any terms in your guess that accidentally solve the homogeneous problem, they're just going to go away when you plug them into the left-hand side of the ODE. All those coefficients, all those terms, they'll cancel out and they'll become 0. Okay? So anything you'd like to include in your guess that would accidentally solve the homogeneous problem, you need to multiply that by a t to get it to show up. Alright, so let's try this out. Find the form of the general solution to this thing. Okay? So this is an inhomogeneous problem. The first thing I'm going to do is solve the associated homogeneous problem. YH double prime minus 3YH plus 2YH equals 0. We'll write down the characteristic equation r squared minus 3r plus 2 equals 0. That's r minus 2 times r minus 1. So r is 2 or 1. So the general solution to the homogeneous problem is c1 e to the 2t plus c2 e to the t. Alright. You should solve the associated homogeneous problem first when you're trying to solve these inhomogeneous problems, because you'll need YH anyway, and it'll keep you from making mistakes when you're doing undetermined coefficients. So now let's go ahead and take a guess at what our particular solution is. Okay? So ordinarily, just looking at the right-hand side of the ODE, I would guess that my solution is like A e to the 2t plus bt plus c. Alright, but if I look at this, that's not going to work. Because this term, this e to the 2t, when I plug yp into the left-hand side of the differential equation, the a coefficient is totally going to disappear, because something in the form a e to the 2t, that shows up right here. This term solves the associated homogeneous equation. So what that means is when I plug it in the left-hand side of the ODE, all of these terms will completely cancel each other out, and that's not what I want. I want them to give me an e to the 2t term. So what will I do? I'll multiply the thing by t. Okay? And then, so now this is my initial guess. Look, b times t, that won't solve the homogeneous equation. C won't solve the homogeneous equation. So you don't have to multiply them by anything. Only this e to the 2t term. So now this is a proper guess at the solution to the inhomogeneous problem. I'd calculate yp prime. I'd calculate yp double prime. I'd find A, B, and C, and it would work. And then I'd say my general solution is C1 e to the 2t plus C2 e to the t plus, and then AT e to the 2t plus BT plus C, but these would actually be numbers if we solve the system of equations. You can't just leave those as parameters, because not any choice of A, B, and C will get you a solution. There's only one specific choice of A, B, and C that'll get you a solution to the inhomogeneous problem. On the other hand, the C1 and C2, any choice of C1 and C2 will get you a solution. Okay, so let's try this next one. This has the same left-hand side, so we know that the solution of the associated homogeneous problem is again C1 e to the 2t plus C2 e to the t. Once we have that associated homogeneous solution, we can write down a guess at what the particular solution must look like. So I'd write A e to the 2t plus B e to the t, and now look, both terms accidentally solve the homogeneous problem. So this term shows up right there, this term shows up right here. If I plugged this thing into the left-hand side of the ODE, both A and B would disappear from the left-hand side. I'd have no e to the t term, e to the 2t term left. I'd have no e to the t term left, this wouldn't work. So what I'm going to do instead is multiply by t. Okay, and now this will work. Once again, I'd find a and b, and then my y would be c1 e to the 2t plus c2 e to the t plus a t e to the 2t plus bt e to the t. Alright, let's continue on. Let's try another one. So to solve this problem, again, I'd solve the associated homogeneous equation yh double prime minus 6yh plus 25 yh equals 0. Write down the characteristic equation r squared minus 6r plus 25 equals 0. That guy isn't going to factor, so r is 6 plus or minus the square root of 36 minus 100 over 2, and that is 3 plus or minus 4i. So the general solution to the associated homogeneous equation is yh equals c1 e to the 3t cosine 4t plus c2 e to the 3t sine 4t Once I have the general solution of the associated homogeneous equation, I'll take a guess at my particular solution. Taking a look at this left-hand side, I would say it's a times cosine 4t plus b sine 4t. Okay? And if we look, none of these terms are going to solve the associated homogeneous equation, right? A constant times cosine 4t is not going to solve the associated homogeneous equation. A constant times sine 4t, that's not going to solve it. So we're good to go. This is the correct guess. Okay, on the other hand, let's try this. Once again, we'll have the same associated homogeneous solution because it's the same left-hand side. Okay, so taking a look at this left-hand or this right-hand side of the equation, I would ordinarily guess yp is equal to, and let's see, I'd have a cosine 4t e to the 3t plus b sine 4t e to the 3t, and we can see that both of these are going to solve the associated homogeneous equation. This guy will, it shows up right there. This thing will, shows up right there. And so I better alter my guess to be at e to the 3t cosine 4t plus bt e to the 3t sine 4t. Alright, and that's that. Now you have all the details of the method of undetermined coefficients. We just had to worry about this case. Well, when does your initial guess accidentally overlap with the associated homogeneous equation? And now we know what to do. We just multiply by t as much as we need to. Oh, one more example. Suppose I wanted to solve this equation, y double prime minus 2y prime plus y equals e to the t. Well, I'd get my associated homogeneous solution, yh double prime minus 2yh prime plus yh equals 0. Write down the characteristic equation. Sorry about that. R squared minus 2r plus 1 equals 0. That factors as r minus 1 times r minus 1. So I have a repeated root here. I have r equals 1 twice. So my YH will be C1 e to the t plus C2 t e to the t. Now let's go ahead and take a look at my initial guess, my YP. I would ordinarily guess that it's some constant times e to the t. Well, obviously a constant times e to the t is a solution to the associated homogeneous problem. Right there, see? So let's X that out, and maybe we should say that our solution is at e to the t. But that also is a solution to the associated homogeneous problem. So we'll just go ahead and multiply t by t again, and we'll have at squared e to the t. And that'll work out just fine for us, and that's it. So if you multiply by t and you still get a solution to the associated homogeneous equation, well, then just multiply by t again and keep going until you don't have a solution to the associated homogeneous equation. And that's it.